Hello, welcome to 8.1 Exponential Graphing and Writing, the first lesson in Unit 8. So we're going to first look at what an exponential function looks like. We have two types. We have exponential growth and exponential decay. So exponential because the variable is located in the exponent rather than as the base or the a value here. Notice we still have h and k, so we're going to be talking about like vertical and horizontal shifts. The a value is going to determine like a stretch or a shrink. So we are going to see that as well. And then we have a new word here called the asymptote. This is an imaginary line that the graph does not cross. So when we're working with exponents, we're going to notice some points that we can never reach because of the exponent where the variable is located. So we're going to kind of see some boundary lines is another way you can think of an asymptote. It's like an invisible boundary. Okay, let's go ahead and try and graph some of these for ourselves. So the first thing we want to note is this is what we're graphing, f of x equal to 2 to the x power. So in this case, since there's no value with x or a value added or subtracted after, we don't have an h or a k in this instance. So we can assume that we're going to be graphing based on 0, 0 as our shift. And that's what we're going to write here, 0, 0 for the shift. Now, growth, and I should have mentioned this up here, but to be a growth function, the b value, which is the part typically in parentheses, but it's the part connected to the exponent, has to be bigger than 1. So if it's bigger than 1, like 2, 3, 4, then we can assume it's going to be a growth equation. A decay equation goes from a large value and gets smaller, and this is a b value less than or equal to 1. Okay. Also has to be greater than 0, so it's going to be between 0 and 1, typically a fraction like 1/2 or 1/3. So we can assume that this one is growth because our b value is the 2, and that's bigger than 1. All right, now let's actually talk about the table, and then we'll get into the domain range and asymptote part of it. So the values we're going to use here every single time when you're graphing exponential functions is -2, -1, 0, 1, +2. Our f of x, which is the same as y, don't forget about that, that's what happens when we take 2 to the power of each of these numbers here. So this one is 2 to the -2, 2 to the -1, 2 to the 0, 2 to the 1, and 2 squared. So 2 squared we've seen before. That's just 4. 2 to the first power would be 2. Anything to the 0 power is 1. Okay, now the negative parts you might need a little refresher on. Remember that this creates a fraction. So this one would be 1 over 2 to the first power, which is just 1/2. And then 2 to the -2 power is 1 over 2 squared, and 2 squared we know is 4, so it's 1 over 4, or 1/4. Notice how the first number and the last, the first number and the last here, those are reciprocals of each other. 1/4, 4, and then the next set, 1/2 and 2 are reciprocals, which makes sense because 2 to the -1 and 2 to the first are connected that way. So now let's go ahead and graph these points from the shift, which is at 0, 0. So 0, 0, and then we're going to go left 2, up 1/4. So just do the best that you can to show that it's slightly above -2. Then it would be -1, 1/2, which is right here. 0, 1 is directly above 0, 0, over 1, up 2, and then 2, 4. So over 1, 2, up 1, 2, 3, 4 is right here. So what we would end up getting is a similar image to what we saw before. It just kind of continues here. And then this is the other interesting part is as you go down the line here, I'm never going to actually cross the x-axis. The reason for that is because this is where the asymptote is located, and I didn't draw it right away, but I will draw them now in the future. So this line here is the x-axis, and we won't ever cross that line. The reason for that is because there's not an exponent, 2 to some power, that would ever get us to 0 itself. We can get really, really, really close, but never get to 0 or below it, like a negative value. Okay, so now what we're going to write here for the domain, we're going to practice writing this format. We're going to use the set notation from negative infinity to positive infinity, because this means the same thing as all real numbers. So you can write the phrase all real numbers, but I'm going to try to stick to the domain being in this format, because this means any value between negative infinity to positive infinity would work. We can get it out of this problem, okay? Because our arrows are going left and right forever and ever. The range is a little bit more specific on this one, because we are restricted to the line y equals 0 and the line y equals 0 and everything above that line. So our range this time is going to be y greater than 0, not equal to, because we will never touch 0, but everything above 0 will work for this. And then the asymptote line, which is this line here, the highlighted one that we drew, that is y equals 0. And we are going to fill that in right away next time. Okay, so that's our first exponential growth function that we graphed. Here's the next one. This time we have a negative a value. We still have the value of 2, so we're going to see the same numbers here. This is just going to make a little adjustment to our table. So the shift is still at 0, 0, because we don't have an h and a k. It is still growth, even though we have a negative a value. That doesn't make it decay. And then what we're going to do now is we're going to see these same values here. We're going to have negative 2, negative 1, 0, 1, and 2. We're only going to look at this part for our table. So we're only doing like 2 squared, or 2 to the negative 2, 2 to the negative 1, 2 to the 0, 1, and 2 squared. So we actually get the exact same values that we had in this table up here. So I'm going to write those down a little quicker. So it would be 1/4, 1/2, 1, 2, and 4. This time, what we do have to account for is the a value. A is negative 2, so we need to take a times y. This is what the purpose of the third column is. So we would get negative 2/4 here if we multiply 1/4 times negative 2. Then we would get negative 1, and we would get negative 2, negative 4, and negative 8. I'm multiplying everything times this column here. And then we're done with this one, so I'm just going to cross this out for right now. We're graphing from the point 0, 0, but be careful when you're graphing with negatives, because now this whole side is going to end up going down. So negative 2, negative 2/4, which is the same as negative 1/2, that's going to go left 2, down 1/2, and be about right there. Then we're going to go left 1, down 1. 0, negative 2 is right here. 1, negative 4 is right there. And 2, negative 8 is all the way down here. So when you connect them this time, this one from left to right, it is, let me see if I can adjust that here quick. Okay, so this one is still going to be a domain of all real numbers, which we're going to represent in terms of negative infinity to positive infinity. This is the same as x being an element of the real numbers. And then the range, I also want to correct this up here. Sorry. If you go to the range, y greater than or equal to 0, that in set notation would be from 0 to infinity. Okay, I just want to make sure to include that. Okay, and then, so the range this time is, since it's going down, we're going to have an asymptote here at the same line. I want to do the highlighted. So an asymptote at the same line, because we can never reach 0. This line is always dependent upon the k value. So whatever the second point value when our h and k shift, that's going to be your asymptote value. So what I'm going to write for this one is y equals 0, because that's the equation of this line right here. This is the asymptote, y equals 0. Okay, the next thing we're going to do is we are going to list the range. Since the range is going down, that would be y less than 0 this time, because everything is below that. So we would represent it, everything going down, so that's why it's less than. And if you're going to write that with the set notation, that would go from 0 to infinity, where we don't include 0. So I wrote that wrong actually. To not include 0, you got to put the parenthesis. So let's go back up and fix that other one I did here, because this one doesn't need the parenthesis. Okay, now we're going to do an exponential decay function. And note, we also have a k value this time. The reason it's got to be k is because it's not with the exponent. Our h value would still be 0. So then it's 0, 2 for the h and k, or the shift. This is going to be decay, and the reason for that is because 1/2 is less than 1, so it's automatically going to be decay. Same x values, -2, -1, 0, 1, +2. The f of x values, though, are going to be a little different this time, because when you take 1/2 to the -2 power, then you flip it, and it becomes 2 over 1 squared, and we know 2 squared is just 4. So now 4 is here, 1/2 to the -2 power, because that would be the next one here, or the -1 power, would be 2 over 1, which is just 2. So hopefully you're catching on to the pattern, but now it's going to go 4, 2, 1. This would be 1/2, this would be 1/4. So it's like the reverse order of what we saw up here in our y column, or the f of x column. We don't have an a value here, so the a times y column is unnecessary. So we can just go ahead and graph, but we do have to graph from our shift. So I'm going to graph the point 0, 2 is right here, but we just want a line going through that. We need to shift. Why do I keep going to that? I want the highlighter. So this is going to be our asymptote line. This is like our boundary line that we are going to avoid ever crossing. So the asymptote is y equals 2, and the reason it's 2 now instead of 0 is because we moved up our line 2 due to the k value. Okay? And now when you're graphing your shift, you're graphing from this point here, 0, 2. That is your new h and k value. So if you want, you can even create like an x and a y axis here. So I could do another, let me do another highlighted color here. So you could go ahead and create like this. I'm just going to shift that over a little bit. Okay, so that's where our new origin is right here at 0, 2. So now I'm going to graph from that. -2, 4 is left 2, up 4. 1, 2, 3, 4. Right here is the actual first point. I'm using a lot of colors here. I'm not used to that. Then we would go left 1, up 2 is right here. And I'm always counting from my new shift point. 0, 1 is right there, 1, 1/2 is right here, and then 2, 1/4 gets really close to the line, but we just don't cross it. So now we're going to connect those. It kind of swoops down, and it gets really close, but it's never going to actually cross the line. Okay, the domain, again, we're going to list that as -infinity to +infinity, because that's all real numbers, all values would be included there. The range is going to be, I'm going to write it in set notation first this time so I remember to do it. It's above the line, but now it's going to be above the point 2. So that's what we're going to use. So from 2 to infinity. And then we would write this as y greater than 2. And I'm realizing that I wrote it wrong in example 3. Hopefully you guys caught that. Let's go back up here really quick. This was less than, so let's just adjust that here quick. Less than would go from -infinity to the point 0. Okay. Continuing on here. Now we've got a little bit of everything. We've got an a value, we've got an h and a k, and we have a different value that we haven't seen for our b value. So the first thing I'm going to do is list my shift point, which x plus 1 is the opposite. So we want to think of that as a -1 and a -3. So that's going to be our shift point. So what I'm going to do then is I'm going to create my asymptote line, which is going to go through -3, since that's the k value. We're shifting the whole thing down. And then -1 Okay, so that's going to be like our new x and y axis. This one is going to be decay because we do have 1/3. That's the part right here. That's the b value. And we can assume that this one is going to have some different values for the f of x. So -2, -1, 0, 1, and 2. Here we are taking 1/3 to the -2 power. That would flip it, and it would become 3 squared over 1, which is 9. If we do the same thing here, we would get 1/3 to the -1 power. We flip the fraction, we get 3 over 1, which is 3. The next one would be 1. The middle one's always going to be 1. And then we have 1 and 2. So it's the reciprocals of these numbers here, respectively. So it would be 1/3, 1/9. And then our a times y value, we do need to include that here because our a is -2. So we would get -18, -6, -2, -2/3, and -2/9. Now the -2/3 and the -2/9, just do the best that you can. All right, graphing from our shift point right here. So -2/18 would go left 2, and it would be down 18, so it would come from the bottom going up. So it would be something like way down here. -1, -6, left 1, 1, 2, 3, 4, 5, 6 is actually right here. 0, -2 is right here. 1, -2/3, we'll try and put a little below, and then closer to the line right here. So this one's a little bit harder since it's coming from off the graph, but we still never want to cross our asymptote line. And then that's our graph. So now when we write this, the domain is still from -infinity to +infinity. I'm going to do it right this time for the range. The range is underneath the value of -3. So coming from -infinity to 3, or if we want to write that as y less than 3, not equal to, because we never cross it. And then our equation of the asymptote is y equals -3. Okay, I almost had it right. Forgot the negatives. Okay. Now we're on to the last part, which is writing the exponential function whose graph passes through these points. All right, so the first thing that I always like to do when I'm doing these, I like to divide it up because we're going to think of this as two separate equations. We're going to be using this equation on both sides. So we are going to start out with the fact that this is our x and our y values for each. So on the left side, I'm going to use the 1, 4, and I'm going to plug it into this equation. Then I'm going to do the same thing on this side, just using the 2 and the 12. So we can assume that 4 is equal to ab to the first power. Then I'm going to do the same thing on the other side, but now I'm going to use 2 and 12. 12 is the y value, so 12 equals a times b squared. Now what I want to do is I actually want to solve for my, in terms of b. So I'm going to divide this side by a. So I would end up with, actually, no. We're going to solve for a, so I'm going to divide by b. I promise you it'll be better this way. So I would have 4 over b is equal to a. Then what we're going to do is we are going to take this value and we are going to swing it in place of the a over here. Because this way we can get it down to a single variable in the same equation. And since we've already concluded that a equals that, we can write this as 12 equals 4 over b times b squared. So if you recall, just make this a fraction. Since there's a b on the bottom right here, and we have 2 there, we can reduce one of the b's. So this would become 12 equal to 4 times b, divide by 4, and we can conclude that b equals 3. Then we're going to take that value, we're going to swing it back over here, and we're going to get 4 over 3 is equal to a. And there we go. We solve for both variables. So to write the final equation, we write it like this. Y equals, our a value is 4/3, and then our b is 3, and then our x value is 1. Which we don't need to write as x. I mean, we need to write as x, not as 1. Okay, last one here, same exact process. We're going to divide the line here. And then we would get, this is our x and our y. So it would be 9 equals a times b to the second power. And this side is going to be 20.25 equals a b to the fourth power. So on this side, again, we're going to solve for a. So I'm going to divide by b squared this time. So 9 over b squared is equal to a. We're going to take that and we're going to swing it over to the a value on this side. So 20.25 is equal to 9 over b squared times b to the fourth. Hopefully we remember what happened in the last one. We can reduce by 2 b's, so we'd be left with b squared. So 20.25 is equal to 9b squared. Now what I'm going to do is divide by 9. Let me pull this up in the calculator here. Let me get the other one. Okay, so 20.25 divided by 9 is 2.25. So 2.25 is equal to b squared. And now what we can do to undo the square is take the square root, and we should get a nice answer here. So I'm going to do the square root button, 2.25, and we do get 1.5. So that means our b value is 1.5 exactly. So then we're going to take that, and we have to remember to swing it back inside of this one, because we need to still solve for a. So this would be 9 over, we just figured out what 1.5 was as the square root, so we can just assume that it goes back to the 2.25 when we square it. And if you divide these, you end up getting 4. So that means the a value equals 4. So our final answer on this one is going to be y equal to 4 times 1.5 to the x power. That would be the equation. And that is it for this one.